let's look at the second part of Unit 4, Section 8. And this deals with something called the discriminant. So the discriminant is the formula for finding that is b squared minus 4ac. And the reason that this is important is because it helps you figure out the number of roots you have and the type of roots you have. And roots is just another word for like solutions, answers, whatever. So the reason that we use this is because it helps us to determine the number of roots and types of roots. And in turn, that helps us to figure out what method is the best for solving quadratics. So we've been over each type of these quadratics. We haven't done graphing, but we've been over, or we're not really going to worry about graphing. We're going to look at factoring square roots, completing the square, and quadratic formula. We've been over each of those methods. Finding the determinant helps us to figure out which method to use. So let's look at this. So the information that this provides to us is the value of the determinant when it is greater than 0 and it's a perfect square. That tells us that we're going to have two roots and they're going to be real and rational. When the determinant is greater than 0 and it's not a perfect square, so we can't take the square root of it evenly, that means we've got two roots and they're real and irrational. I don't have enough room. Let me just write it. Irrational, and I'll abbreviate it. So the first difference is the first situation, I guess the first two situations is once you take the determinant, when it's greater than 0, you need to take the square root of that to figure out if it's two roots and rational, or if you can't take the square root of it, it's not a perfect square, then it's going to be two roots and irrational. And you'll see later on that we work these, you'll see how those can tell you which method to use. But for now, this is just introducing you to the information. So then you can run into an instance where your determinant is equal to 0. And when that happens, it means you only have one root and it's going to be a real and irrational. Or it's going to be rational, actually. I don't know what I'm talking about. It's going to be rational. So that just means you'll have one answer. That's all that's pretty much saying. And then the last part, or the last situation, last scenario, is when your determinant is less than 0. So it's a negative number, or it's a fraction that's less than 0, like 1/2, or I guess that's actually greater than. So I guess it would just be all negative numbers. So anytime you have your determinant as less than 0, that means you have two roots, but they're imaginary roots. So they'll have I in them. So I can't remember how you spell imaginary. Imaginary, is it ER or AR? I think it's ER. I hope so. Imaginary. Okay. But that is all the scenarios you could get into with finding the discriminant. So the discriminant tells you all those 4 different things. So just make sure that you use this graph to help you. So you need to get this information written down, and you need to make sure that you know each of these. You need to make sure that you know that when the determinant or the discriminant is greater than 0, that means you have two roots, and then you have to look at whether or not it's a perfect square. Because if it is a perfect square, it's going to be a real and rational type of root or type of roots. When it's not a perfect square, it's going to be a real and irrational. And then you need to know when the discriminant is equal to 0, you have one rational answer. And then when the discriminant is less than 0, you have two imaginary answers. So in each of these problems, we'll look at each type. So let's look at these. So in number 1, we need to find the discriminant. So I suggest you go through and identify A, B, and C because that's what you use. So A is going to be 2, B is going to be 12, and C is going to be negative 13. And then you use this formula, B squared minus 4AC. That will give you your discriminant. So B squared is going to be 12 squared minus 4AC, which will be 2 times negative 13, which will give us 144 plus 104. So that's going to equal 248. So that is your discriminant. Now your discriminant will tell you the number of roots, or the number of roots and the type of roots. So our answer is 248, which is greater than 0. So we're looking at these two columns now. We've eliminated these last two columns. So let's just look at the first two. Now we need to figure out, is 248 a perfect square? Can I take the square root of it evenly? And you can't. So that means that we are done with option 1. So that just leaves us with our discriminant is greater than 0. It's not a perfect square. So our answer is going to be 2 real irrational answers. So that's all you would have to write for this, is 2 real irrational roots. So that's an example of that. Now let's look at number 2. We'll probably go through each of these so you can see them. And I'll try to go through them pretty quick so this video is not too long. But let's take a look at number 2. So the first thing you need to do is identify A, B, and C, like we did here, but I'm probably going to skip that just so I can crank these out for you. So the discriminant is B squared, which would be 16 squared, minus 4AC. A would be negative 1, C would be negative 64. So then that would leave us with 256 minus 256, which equals 0. So our discriminant for number 2 is 0, and that leads us to this column. So when the value of the discriminant is 0, that means we're going to have one root, and it's going to be a real and rational. So that's all you would have to write for this. You would just say 1 real rational root. So thus far we've had an example of D greater than 0 and it's not a perfect square, and D greater than, or D equal to 0. And D is just the discriminant. So let's look at 3 and 4. So on 3, we're going to be using the discriminant formula again. So just make sure that you know how to plug these in. When we go through and identify each of these, just notice that this needs to be in standard form. So it would actually be rewritten negative 4x squared plus, actually minus 10x plus 81, or 84 is equal to 0. So when we're determining what A, B, and C is, A is negative 4, B is negative 10, C is 84. So when we plug that into our formula, it'll be B squared minus 4AC, which is negative 4 is A, C is 84, and that's going to give us 100 plus 1344, which will end up giving us 1444. So that is our discriminant. Now, our discriminant is greater than 0, so we're only looking at these two top columns. Now we have to figure out, is that a perfect square? And it is a perfect square, so we're actually only looking at this top column. So when our answer is 14, our discriminant is 1444, that's a perfect square. So that tells us that we have 2 roots, and they are real and rational. So your answer for 3 would be 2, real and rational. And then we'll work the last problem. Just make sure to notice on the last problem, we've got 3x squared plus 24. There's no x term. That means that b is going to be equal to 0. So we're going to have 0 squared when we use the formula for discriminant, minus 4ac. A is going to be 3, c is going to be 24. So that's going to give us negative 288. And when our discriminant is less than 0, that is our last column, that means we have 2 imaginary numbers, or 2 imaginary roots. I'll put imagery. It would be imaginary. Can't spell. All right, there we go. So those are all the 4 different types you could have. Now, I'm going to help you with choosing the correct method by giving you a chart to tell you pretty much when to use each one. So we've been over factoring, square roots, completing the square, and quadratic formula. We use the discriminant to help us figure out which methods to use. So I'm going to give you this chart, and it's going to help you on what your homework's going to be. And so please get this stuff written down and pay attention to it. So factoring can be used sometimes. This isn't as important because I'm just going to tell you when. So don't worry about when it can be used because they can always be used in different scenarios. Just worry about the when column, like when can I use them. So when should you use factoring? When your roots are rational. So when our roots are rational, we would use factoring. So if you look at this, if you look at our examples we did, on number 2 we could use factoring, and on number 3 we could use factoring because both of those roots are rational. We wouldn't be able to use it on 1, and we wouldn't be able to use it on 4. So that's an example of that. Now square roots is, when would you use that? When there is no b term or x term. So if you notice on number 4, there's no x term. We could have used square roots for that. We could have solved that by using square roots. Now for completing the square, on completing the square and quadratic formula, these can always be used, but sometimes it's just better to use them in certain instances. So when do you use square or completing the square? So when there is no x squared coefficient. Can't remember how to spell coefficient. Coefficient, I think. Maybe. So when there's no x squared coefficient and there's an even x term coefficient. So let's see if we had one of those. We actually didn't in any of these, but you'll see when we do the homework there is one. So there's no really good examples for that, but you could actually use that on either one. But they're best when there's no x squared coefficient and an even b squared or b term or x term coefficient. So now let's look at the quadratic formula. The quadratic formula can be used at any time. Just make sure you use it when all the others aren't. So when all others aren't efficient. My handwriting's terrible. So pretty much use quadratic formula as the last case scenario. So just a review. When you're factoring, or when you want to choose which method to use, pick factoring when the roots are rational. So like in number 2 and number 3, we said, okay, those are two real rational roots, so we can use those. And then square roots when there's no b term, like in number 4, we could use that. Completing the square would be best to use when there's no x squared coefficient and an even x term, and you'll see one of those on the homework you do. And then the quadratic formula is pretty much used as the last resort. And we'll go over these. I'm going to have you do an activity where you pick which method to use so you can practice these. The important thing is to be able to find the discriminant, because once you find the discriminant, you can use this table to tell you everything you need to know.